Hi there, Mr. Putnam here. I want to help you with this Kepler's laws assignment in planetary motion. I know some people have a little trouble calculating the orbital period and the semi-major axis, and figuring out how to manipulate these numbers, especially when you're dealing with a square and a cube. So we're going to work on that real quick, and I'm going to show you how to do that on a calculator really easily, because I know that might be a little bit difficult. So remember that a square just means a number times itself, and that a cube means a number times itself 3 times. So a times a times a would be a cubed, whereas p times p would be p squared. So that's the simple way that is. Now the weird thing about this is just sort of the genius that Kepler figured out, that the square of the period, how long it takes a planet to orbit another object in space, or the sun, is proportional to the cube of that semi-major axis. So if we know the distance of the semi-major axis, how far it is from the object to what it's orbiting, then we know that if we cube that, that's going to be proportional to the square of how long it's going to take that thing to go around in its orbit. And so if you know one of those things, you can calculate the other one. So in this case, we know that a planet has this orbital period. It takes 2.56 years to go around the sun. So we can figure out then its average distance, which technically it's not the average distance, but it's close to the average distance, so we'll just say that. The average distance of a planet being somewhat equivalent to the semi-major axis, how far it is at that point in its orbit. So all we do then is plug the number that we have in. So we know that p, the period, is going to be 2.56 years. We put that in, 2.56 squared. You can do that on a calculator just by multiplying it times itself, right? That's easy. 2.56 times 2.56 is going to be 6.5536. And that's going to equal then, that 6.5336, a cubed. And what they've already jumped ahead and done here in this next step is then they've said, well, if a is cubed, well, we want to find out what a by itself is. So we're going to take the cube root of both sides of the equation, and that's going to make sure that we maintain the equality of the equation, the equivalence. So we take the cube root of a cubed, and that's just going to give us a. If something is cubed, and then you take its cube root, that means you're finding out what times what equals that something. Well, that's just going to be a, so you're getting back to a. But the harder part, for most of you, is going to figure out, how do I take the cube root of 6.5536? Well, you really need a calculator to do that. What that's saying is, what times what is going to be 6.5536, if I'm figuring out what the cube root is. And to do that, you probably need a calculator. Now, when they multiply something to the 1/3 power, that's the same as taking the cube root. It's kind of inversing the idea of a cube. And the way you do that on a calculator is just like this. And I would go to your Desmos calculator, which your math teachers love. And you can find this here is one way to do the cube root, where you have the n with the check here. And if you just put 3 in there, that's going to be the cube root of whatever number you have. And in this case, it was something like 6.5536 or something. And that's going to give us 1.871. You can see that's the right answer if I go back here to 1.871, right? Another way to do it is obviously to use that 1/3 power as well. So you can also go to the calculator, and instead of doing it that way, you could go a to the b, and so I would go 6.5536. I guess I have to do that first, and then a to the b. So it's going to make a little superscript there where I'm going to put 1/3. And you can see that once I've done that, 6.5536 to the 1/3 power, it's going to give me the same thing, 1.871. So there's 2 different ways you can do that. But this is basically how to solve this equation when you have a square being equal proportionally to a cube, and you have one number. How do you then get the other number? Well, if you have a squared, you do the math, or if you have the b number, you do the math on the b number to figure that part out, and then you have a squared equals some number. Well, then I have to figure out if a times itself equals some number, then I have to figure out what a is. Well, that's going to be the square root of that number is going to be what a is. Good luck. Call me if you have any questions. I know this can be confusing.